not given access.
Okay.
Okay, fine. Okay, good evening, everyone. As a continuation for our collection framework, so let's recap. So we have discussed about the list interface, then set interface, and we got the introduction for the map interface. So list is the one like whenever there is a requirement, you want like ordered collection means order should be mandatory in such cases, and also like your requirement says that like no, the duplicate should be allowed. So in such cases, you'll go for the list. And if your requirement says that like you need only unique elements, means duplicates are should not get allowed. So in such cases, you'll go for the set. So within the set, like if order constraint is also there for you, so accordingly you can choose either hash set or linked hash set or tree set. Okay. Similarly, like you want like unique constraints, and at the same time, uh, the object. So it's not a single and it's a key value pair. In such kind of requirements, you will go for the map interface. So within the map interface, as already discussed, there are the three types: the concrete classes, so hash map, linked hash map, and tree map. So we have seen the program for the hash map. So the API level, like whatever, like it's almost they try to make it as similar so that like the memorizing wise and the practice wise it will be easy. So the only the thing the difference is here the put method they were using for inserting, I mean adding a element to the map, and at the same time the inside elements are stored as a entry. So entry is the object, array of entry objects is the map actually. So let's see the program. Yes. So I think already we covered in the last. So creating the object is almost similar. Like most of the places I'm using the default constructor, and also I'm using so add all also like means already some collection is there. From that collection, you want to bring up another collection. I have given like a couple of examples for that also. Because if you see all other set classes, so from array list to set and one has set, another has set. So these are the examples I have shown. So here, as I mentioned, as a put is a one, as a functions like for adding the elements to the map interface, and contains key. So key is the one like which maintains the uniqueness. So that's where like contains key you can check whether any key is present or not. Then getter is the one like based on the key index, like you can get it. And we are having a key set. I mean, because it's a key value pair. So there is a possibility like all the keys you can get it by calling some particular function. At the same time, you can get all values by calling particular function in the map interface. So the if you call the key set, so what it will return, let's look, see, it is written in the set. Set is nothing but collection of elements, right? So all the keys, so whatever keys are available in hash map, so all those keys will be written in the set format. So if I want to get all the values in the set format, like I can get by calling the values. Otherwise, I want all the entries as it is, means as a key value pair. So that's where it returns entry object. So it's nothing but array of entries, right? So each entry object represents like one key and value. Okay. So here, like we can traverse, like there are the two ways. So iterator is the one thing. So generally, like no, for any collection and traverse through the collection. Also, like we are having other alternatives like for each loop. Okay. So either by using that or this, we can traverse through the map elements. So that is the one for hash map. So hash map, as we have seen, the difference is it does not guarantee any order actually. Okay. Now let's for linked hash map. Yeah. Let's see. What are all there? See linked hash map. So initially I have taken the default constructor. which is the easiest way for creating any collection object. And look here. So I have added two elements. Okay. Then I'm printing that. So here I'm using another type of constructor. So what I'm doing here is I'm taking existing map, means I'm creating another map by adding all the elements of another map. So this is another type of constructor which is available. So for the example sake, I have taken that also. So after that, I'm adding like another elements. So when is 3. So I'm putting. So then there is also one more function like put if absent. So there is the one thing like which will check if it is not present, then only it will add. If it is present, then it will not even add. So that's a flag base, this one. So then again, like key set, values and entry set. These are all the things common like hash map. So let's execute this code. See here, first I have added 2, 4. So these are the even numbers map, linked hash map. Then after that, 2, 4, 3, 2, 4, 3. Okay, then like I'm looking for 6 and the updating. So if it is not present, that's why it is getting added. If I see here 2, 4, 3, 6. So 6 also got added. So if you see the difference here, like the order means wherever you are seeing, the order is the same. So however the way I have added the elements to the map and the same way I'm retrieving. So that is a major difference between hash map and linked hash map is hash map does not guarantee any order. But in case of the linked hash map, it guarantees the order. That is insertion order. Okay. So this is the one for linked hash map. Let's go for another last map, tree map. So here also same thing. I have taken even numbers with the tree map 2, 4. I have added the elements. Then again, I'm added the 6 also like so. These are just different methods that just to show. So for adding or removing or traversing, it's a single like no direct already every all functions are available. Just you need to call the API calls. That's it. Okay. Then again, I've created one more map. So I've added the element. Then I've added all the other map actually. So what I do here, I will add I will add all those first, then I will add this element. So then entry set, key set and values. These functions are remains the same. Okay. And I'm traversing through each things and I'm printing it. So the function wise, all are same for each map, concrete map implementation. So the use case only varies actually, which one to choose when. What is null point exception? Trim map 40. What we have done? 40. Not removed anything. 2, 4, 6, 1. So 3 is not there here. It returns null. Or if it is not present, it returns null. Numbers, are we emptying anything? even numbers. 3 elements are there. Then I'm adding numbers. I'm adding numbers to okay. Let's keep this aside. Let's see. Yeah. Let's see what and all we have done. First, I'm adding even numbers 4, 6, 2. Yeah. If you see in the starting itself, you can see this. What I have added 2, 4, 6. Okay. I have added in the different order 2, 4, 6, but the elements are represented here 4, 6, 2 because that is tree map works on the sorting. Okay. Sorting means it will compare and whichever is the lowest one means default is the ascending order. So if you see F starts the first, right? Then O and S and T, F starts the first. So that's why we can see the elements are sorted in the ascending order. So this is the default sorting for the tree map. So the major difference we can see between the things here, like the ordering of the elements is only the difference. Okay. So this is the key difference for tree set and linked asset I have shown you. So elements are stored and retrieved in the insertion order. So whatever the order you have chosen, the similar way elements got retrieved from there. Okay. So but here we can see sorting order has taken place. Clear? So this is about tree map example. So let's go for differences actually. Okay. Sorry. So these are the one like within collection, I means map implemented classes, what are the difference are there? So one is the order. So hash map, as we mentioned, it will not guarantee any order. Okay. So tree map is the one like sorted order. So default is ascending order. And if you want like specific order, we can define it. I will explain the coming slides. Okay. Linked dash map is the one which is insertion order. Okay. And get put remove under like so what is the performance. So in case of the hash map it's always O of 1 means it's a straightforward like it gives a better performance. In case of the tree map it is log n always because it has to compare and identify like no according to the comparator logic we will provide. So it has to do these calculations, so that's why it takes time compared to this one. So tree map as a complexity is log n for insertion and lookup. So it's also like it's almost similar to the hash map, but it's slightly lesser than hash map because even like no the internal structure is different for this. Okay. So interfaces. So hash map implements like map interface and tree map like it's a navigable map and sorted map. So this is it implements the three interfaces and linked hash map is anywhere like map interface. Okay. Null values. Okay. So as we know that it it will not allow any duplicate, but max of like one null key can be inserted in the hash map. Similarly for the linked hash map also one null key can be presented. But in case of the tree map, it will not allow any null because it has to do the object level comparison, right? If any object is a null, on the top of that, if you are trying to compare, it will give the null pointer exception. That's why it's mandated that key tree map should not allow any null value, null key here because of the comparison time, like it will throw the exception. So that is the reason. Okay. Fail first behavior. Okay. Fail first behavior is another topic which we'll discuss in the coming sessions. So whatever the iterator is there, right? So which is retrieving or traversing through the elements. So that gives a concurrent modification exception. Okay. So fail fast and all iterator whichever is following, right? All are like fail fast. High level here fail fast means, so if somebody is iterating through any collection, if other person and come do the changes, then it will throw the concurrent modification exception. Okay. So how we will achieve under, like we'll see in the programmatic later case. So implementation, like hash map is backed by hash table. So those are nothing but buckets. And tree map is red black tree. Okay. And this one is W linked buckets. So the internal structure it is carrying. So and synchronization wise, if you see, look, none of the things are synchronized. So all these things are like no non-synchronized. So if you want like any synchronization behavior, there are other options available. Let's see like, so the requirements like when to choose, it's clear. So you know that. So order is only the one which decides actually. So if no order is there, always hash map is the one which provides always the better performance, and storage wise also it's a better. Okay. So these are all the things like comparatively. So based on these comparisons, we can choose according to your requirements. So which one suits best? Clear? Any doubts in this? And the map interface. If nothing, like we can proceed with the other things. Okay. Before going with the further topics, there is a one utility class in collections. So we have shown all the interfaces, but there is a one utility class which provides like a lot of common implementations. Okay. So those are like majorly. I will highlight the main things. It's not collection. Collections. Yes, this is the one. You should know there is one class which is providing no many utility functions. Okay, common functions under. Okay, so if you want to do any binary search within your collection and queue related checked map, so I will explain. I will take a couple of the things. Let's go for synchronized first. Yeah. See, by default, like any list implemented or set implemented or map implemented classes are not thread safe. Okay. By default, those are not thread safe. So, but if you want to make any collection as thread safe, we are having the functions API is available actually. So that is the collections. Okay. These are all static functions. So by using the class name, we can get called collections dot synchronized set of by providing the set. Let me create that and show you. Yes, I will take as a set, but it's a common for everything, anything. So the API remains a common set of. What is the type? Integer. Synchronized set is equal to collections dot. See, if you see here, by calling the collections dot synchronized, these are all the functions are available. One is if you have the collection. So you have one collection, you want to make that collection as a thread safe means synchronized. So in that cases, you can call this first function. In the second one, you are having the list. You want to make that as synchronized. So you can call the second. And also map also we have, set also we have. So this is the ready-madely available API. Okay. So just by calling this synchronized setup, so which set I want to make it as synchronized? Numbers. Okay. So like this, by calling, it will create another set, which is by default thread safe. The element, this set got created from this. Okay. Means I have one set which is not thread safe. So now my requirement from this point onwards, it should be thread safe to continue further. So in such cases, what we will do by calling this collections.synchronize set, it will create another set which is of thread safe. So this is how you provide thread safety for your collection classes. If it is a list or if it is a map or like if it is a set. So for all these things, you can do by this way. Is that clear? So collections dot synchronized. So this class is having like many such things. Okay, if you want to swap the elements in the positions in the specified list. So like generally like we don't have that provision, right? So simply we were adding. So later like we realized so some two indexes values needs to be swapped. So in such cases, what we will do, we'll go for this collections dot swap function. Okay. And also if I want to do sorting, okay. If I want to do sorting, so then I can call the sort function collections dot sort. So by calling this, like no, it will sort the collection. Also, like we know that like singleton. So if you want to make any our existing collection a singleton, okay, you can make it as by calling the singleton list. So we don't remember as of now the singleton and all we will be covering in the coming sessions. But the idea is it is having like no many functions actually. So sorted, and if you want reverse order or if you want to reverse the string or list. So if you want to replace all, so these are all the things means already available, ready-madely available. If you want to shuffle randomly perfumes and specified list using a default source randomness. Also like checked, unchecked. So min. So if you want to get the minimum element, if you want to get the maximum element, okay. So these are all the things are available actually. Just by calling this particular one, you can get all these things. So you people have to go through this collections class. So what and all the functions are there, and all these things. The frequency is there, empty set. So if you want to create like empty set, okay. So this is immutable. Mutability, immutability, are you know, right? So immutable means it's kind of string. So once it is uh, try to modify, it will create as another object. So you cannot change particular object. So that is called like immutability. Okay. So if you want to create a empty iterator, so just you want like iterator object with empty. So these are all the things like you can use. Yeah, this is the one like checked. Checked is the one like type conversion. So from some type to some type. Returns a dynamically type safe view of the specified set. So type safety it will provide. Then rotate is there, and singleton already we discussed, fab discussed, synchronization we discussed. Yeah, unmodifiable means I mean you cannot modify it. So I, I have some collection. So I have used for some time. So I'm done with my all insertions. And now onwards, like no, my requirement says that like this collection should not get modified at any point. So in such cases, what we will do from that collection, we will call this API and we will generate the another collection like which that cannot be modified at all. Okay. So like this, these are all the readily available things. So we need to understand, like go through this classes, this class, and understand the methods, what and all it will do. Okay. Now the next topic is sorting. So because why I have shown this one is The one is a one. Just you people should know that, like, because by default synchronization is not supporting. So that's why I mentioned, right? So none of these things are like no synchronized. But if you want to use as a synchronized, so there is already option like just by calling one API, so your complete collection becomes a synchronized. So you should know that. Also, one more thing is, before going for this from synchronized, there is another topic called hash table in Java. Okay, this is a very legacy class. Okay, but it is also similar to the hash map. That only difference is it is thread safe. It's a synchronized. So generally what happens is if you have key value of pair and you want everything to be thread safe, in such cases, ideally we will go for the hash map, hash table. Okay. So if it is like no thread safe is required, then hash map is the best choice. And if requirement says that like no everything should be uh, thread safe, in such case we'll go for the hash table. Okay, detail I will talk in next class. Like that is a Java topic is there. I will link this one with that. Okay, now look for sorting. So as of now we know that how that sorting can be performed. Okay, so we know that like in case of the set and map, there is a one concrete class which is providing by default sorting. So which is tree set or tree map. So what was happening in case of the primitive? For now we have seen only the primitive. Primitive type means default, like no JVM decides the ascending order. So but in case of any customized class we are having, the object is customized, means like any employee, any student. In such cases, like no, how this sorting works, we'll see. Okay. So basically, to achieve sorting, there are two ways actually. So one is either you have to implement the comparable, means comparator. Okay, another one is comparable interfaces. There are two interfaces, comparable and comparator. Let's start with comparable. See, this is one comparable interface. Let's go inside of it. What and all it is having. So this is a Java, like it is coming as part of RT.Java. So it is having compare to function. Okay, this is a one interface and it is having compare to function. Okay, generally this interface used for sorting. Okay, compare to means you want to compare to with this object. So in such cases only we'll go for this. So sorting means we need to compare and identify like which is a higher and bigger, lower. So accordingly we will place into the order. Okay, this is a comparable interface. This is a one option. Okay, first we'll go through in and out of this option, then we'll discuss about the other one. So how we will implement is, so I've taken the employee class. This is a customized. It's not like inbuilt. So that particular class should implement the comparable interface like this, implements comparable. So as we know, this employee class is having four fields. So employee ID is there, employee name is there, employee age is there, and also employee salary is there. Okay, these are the four fields defined for this employee class. So I have all the getters and setters for this. Okay, get ID. If I want to get ID or name, age, salary, I'm having all these things. Okay, getters. So I can, by calling this particular function, I can get a specific field. Now also I'm initializing this as part of the object creation. During the object creation itself, I'm initializing. That's where I'm having this parameterized constructor. So if you see here, so I'm implementing this comparable interface. I need to provide implementation for compare to, because comparable is the interface which is having the compare to abstract function. If you see, this is an abstract function because there is no implementation. So it's only signature is present, nothing else apart from that. Okay, that's why it is abstract. So any class which implements the interfaces should provide implementation for all its abstract functions. So if you see here, we have only one function, that is compare to. So this employee function should provide the compare to logic, means implementation. So what we are telling here, so I'm comparing with the current employee object with whatever the employee object coming as the argument. So what I'm doing, I'm comparing by ID. So employee ID. So whoever is the lesser, like comparative function, right? If both are equals, it returns a 0. And if the first one is the bigger, it returns positive. And if second one is bigger, it returns a negative integer. Okay. That's how the comparison works here. Then this is a true string. True string is nothing but like however you want to print your object. So that's it. So let's see here what I have done here. So this is just array representation. You take light for now because we look for collection perspective more than array here. Yes. What I've done here, I have created one array list here. So if you see here, the data type is an employee object. So previously we were doing like integer or string or anything, right? So that's a called like generics. So generic concept in Java says that. So during the creation of the collection itself, you should define what kind of data type it is going to hold. So then I have added 4 objects to it. Okay. So if you see, I've created object here by calling the new employee. So this can be similar, like you can create like employee E1 is equal to new employee of this, employee E2, employee E3, employee E4. Then here you can add E1, E2, E3, E4. So that is also one way. So I don't want like any references and lines of code will be reduced. So directly I can create object here. So what it will create the object and that will be added for this list. So similarly, I have done for 4 actually. So then what I'm calling collections dot sort. So this is the one function like no for sorting the list actually. So if you see here list, this sorting is happening like this. Oh, still it is executing particular one. Name I need to change. Let me. This is the one like we can place a number of classes in a single class, but only the class is which is executing that only should be public. You can have like you cannot have more than one public. Okay, now it's solved. Fine. See here, I have added 30, 10, 5, 40. 4 elements I have added. Then what I've instructed, so you sort based on the employee ID. Okay. So now it will look like employee IDs will be going for ascending order. So first it should come as 5. Then it should come as 10, then 30, 40. Let's see. See, first we can see as 5. Okay. Then second we are seeing as 10. So third is 30 and another is a 40. So if you see, so everything it works properly. Okay. So you understood, right? So how this sorting is happening, it's purely based on this implementation. So let me change this to some other. Instead this here, let me keep this. Let's see what happens this time. See, this is a descending order. See, it's where is the console output? It started with 40, 40, 30, 10, 5. So this is how like no, I'm instructing like because it is my customized class. So however I want the sorting to be done on this particular object, who can define? So that can be defined like this. So I have used comparable interface. So within that comparable interface, there is a function called compare to. Here I will decide like how the sorting should be done. If you want ascending order, I can define like this. Or if you want like salary base, it should be done. I can use a salary also, employee got salary. Or else even in the name base or age base, anything I can do here. Okay. Based on that, it will return. But generally, why I did not take any other things is because even with the same name also, there can be multiple employees and even age base also like no same age group, like there can be multiple employees and salary also like according to the destination, I mean designation, they'll be maintaining some standard salary structure. So if I want like no better uniqueness, so that's where like I have chosen the employee ID. So employee ID is the one always like unique. Every employee will be having the unique key ID. So that's why I've used this one. So, but however you want, like you can define according to your requirements here. Okay. That way we can achieve the sorting actually in Java. So now I have explained one option. So there is another option actually. So which is comparator. So there are the two interfaces. Let me go for that. Yes, this is the another interface, which is comparator. Here I have compare function. Okay, compare. So I will pass two objects. You compare between them, and it will give the result of it. So if we are going for this comparator interface, we need to provide the implementation for this compare function, or else we are having this comparing like no, we are having like comparing int, comparing long. So many other functions are there. If you see, these are the static one. So these are not the abstract. So these are already implementation is already available. So we can use this also like reversed or reversed order. So however you want, we can use it directly. Collections dot reverse order. Okay. So let's see with the comparator example. So I have student actually. So student is having a roll number, name, age. Okay, I'm having. Then I have one constructor. So for initializing. So then what I've done is I have created one separate class. So let's take that is class age comparator. So based on the requirement, like no, if I want based on some particular field, I can go for it. So now I have written one comparator which compares based on the age. Okay, implements comparator and it provides implementation for compare function. So I'm passing two arguments. So from both the things, it will fetch the it will do the comparison like this. Okay. So it is converting first to the string, I mean, student objects. Okay. Typecasting it is doing. Then based on the typecast, it is getting the age and it is comparing. So which one is a bigger, which one is a lower. So if both are same, it returning one. And if first one is a bigger, it returns a positive integer one. And if the second one is bigger, it returns a negative integer one. So means if you see the difference wise, uh, in case of the comparable, whatever the class or whatever the object we are thinking, that object itself should implement the comparable interface. Okay. And here the implementation should be defined and predefined. Okay. So, but in case of the comparator, it is not the case. So according to our requirements, we can write new comparator. So let's see. Initially, I thought like, oh, okay, I want comparison with the age factor. So now I decided, no, I don't want with the age factor. Now I need with the name factor. So in such case, what I do, I will define one more comparator. So that should work based on the name. So, but when you go for this comparable, you don't have that flexibility. If you want to change anything, you have to change the core class. Means the core class, which is employee here, because here everything is working on the employee object. Means collection of employee objects, and class is the employee class. So now here my logic is there based on the employee ID. Okay. Now, if I want with employee name, what I have to do? Again, I need to come here. I need to change this class. Okay. That is not the good practice. So whenever you write the code in such a way that it should not like no modifiable, means for any kind of requirements. It is always good for enhancement, not for the modification. That is also one of the design principle in Java. Like, okay, open close principle. One is open for enhancement and closed for the modifications. So that is not the good practice, like keep on coming and changing this particular class itself. So in case of the comparator, what I've done, I simply created one more class, which is implementing the comparator interface. That's it. I changed just whatever I'm passing here, right? Here I changed. So everything works for me. So this is a better option. If you don't know, means your sorting factor is a dynamic. So let's see, I've created one array list. So then I've added 3 elements here. Then first I'm sorting by name. Okay. So if you see here collections.sort. So initially I have used just collections.sort. I did not provide anything. See, I can show you here itself. See, edit collections.sort of employees. So means employee itself is a comparable object. Means because it is implementing the comparable, right? So that's only one argument is fine. But when it come for here, I'm working on the student object, means list of students here. Then I have the separate comparator for sorting logic. So that's why we need to provide 2 arguments. Let's see what this constructor says. See, sort, one is a list it should provide, another is the one comparator. So if you want in more detail, I can show you. See here, sort only the list. Means whenever you provide this complete single itself, means whatever the object that list is carrying should be implementing the comparable. But when in case of the comparator, because for the comparator there is a separate class. Okay, that's why you need to pass that as a separate argument. Okay, you should remember, like in case of the comparable, the particular class itself implements it. So you need to provide separately 2 things. So everything is aligned in a single class. But when it comes for the comparator, so comparator logic is there in separate class, and your actual entity is a different object. Means the list is carrying different object. That object is having nothing. So that's why you need to pass 2 things. So here says that this is my collection, you need to sort, and this is how we need to sort. That is a comparator. Okay. Let's execute now. See here, name wise, if I search AJV, it's done, right? So, but here Ajay is having 27 years, Jay is having 21, Vijay is having 23. But according to their names, so alphabets, right? It started. But second, when I search based on the age, see the order is changed here. So here when you see 27, 21, 23 was their age, but the name is the one took the precedence. But when it comes here, it's the age is a factor. Okay, because I have created two comparators, one for age. So what I have done, I have created one array list. I have added 3 elements to it. Then here I have passed name comparator, means you go sort based on the name. So then what I'm doing, I'm printing all those elements. Similarly, again, what I'm doing, again, I'm sorting that particular collection. This time I'm sorting based on the age comparator. Okay. When I sort based on the age comparator, then again, I'm printing the all the elements. So that's where we can see here. So two different outputs based on my input. So now what happens is, if I want like ID base also now, so what I do, I will not change the core class, which is student here. I no need to change anything for that. So I can add like class ID comparator implements comparator. So here I can provide public int compare object o1 object o2. The logic remains the same. I think everything remains the same because it is integer level comparison, right? So can keep the same thing. So now what I do is, here I will add this one. So if you see here, I did not change anything on the existing. This is the one. Here also new logic I'm adding, there also new one. So that is one best advantage for this comparator. Sorting by ID. ID comparator. Here duplicate. So I need to give this 3, 3. That's it. ID logic is something wrong. Where it is? Oh, sorry. Here I did not change this ID. That's why you can see the output as same as before. What is the field here? Roll number, sorry. Yes, roll number it is. Okay, let me execute now. I can see now. See here, when I went by name, so irrespective of the roll number, it took the precedence only with the names ascending order. Then second attempt, I tried with only age. So irrespective of other two factors, age took the precedence. But in the last one, I tried with the roll number. So if you say roll number 101, 105, 106, see it worked. The comparison happened. The factor is roll number here. So this is how like no we will do the sorting for user defined classes. So is that clear? Oh, let's do the comparison. So which one to choose when? So it's always like these are all the provisions available in Java, but when to choose what is the deciding factor. Okay. Let's see the difference between comparable interface and comparator interface. Okay. In Java 8, in comparator interface, there are like many of the functions, the default static functions they have defined. So reverse order. So directly it will give in reverse order. So these are all things, default functions they have added in Java 8. Okay. So you don't need to do multiple things and all. Directly you can get it. So if it is you want in descending order, you just do if you want reverse completely, it can reverse and it can take the reverse order. Even comparing also like integer level, long level, like anything like you can do explicitly type wise. Okay. So comparable, it provides only default or one sort of sequence and we cannot change it dynamically. I told you, right? So during the class creation time itself, if you know, means before itself, you know, okay, my requirement says that like, okay, there is a employee object is there. The sorting always employee ID. So it is fixed. It will not going to change in the future also. Means it's a damn sure. In such kind of cases only you can go for the comparable. Okay. It provides only default or one sort of sequence. Only one sort it will provide and you cannot change that in between. Okay. You know, predefined everything very well in advance. In such cases, you can go for the comparable. Okay. In case of the comparator, you are having like multiple sequences actually. So dynamically you can change. So I shown you, right? So age base and ID base and also name base. So these are all the flexibilities available for me. So in case of the comparable, I have to go to this employee class and I need to change the existing implementation of it. So here, I will not change anything. Like I will write the new logic and I will just my main reference I can change. That's it. So that is the way like it can extend. Okay, that's the main advantage and that's the main deciding factor as well. Okay, and comparable interface, it is having one function, abstract function, that is compared to. Okay, in case of the comparator, it is a compare function. Okay, it is part of like language package. Java.lang is a default package in Java. So this interface is part of lang package. But in case of the comparator, so it is part of util. So all this collection framework kind of like no, these are part of like util package. Means list, set, map, all the iterator. So all these kind of things, these interfaces and classes are there from util package. So if you implement the comparable interface, actual class is modified because as shown, right? So whatever the class is implementing, I mean, wherever we need the sorting, that particular class itself should implement it. But in case, so actual class, like no need to touch anything. So actual class can keep as more generic and comparator wise, I can write as a separate class. That's the one thing. So uncomparable means generally like the predefined are there, right? All primitive type like all these wrapper classes are there, right? By default, they will implement the comparable interface. Okay. So custom object like wherever this util package classes are there, right? That's where like you can use a comparator interface. See wrapper classes string implements comparator interface by default. Okay. So for this comparator, like it's a dynamical. So any class wants to implement. So that's where, like, if you remember, collection that sort tree map and all, like they were giving in the sorting order, right? Because they have there we have chosen only the wrapper classes. In case of the tree set and tree map, So those were giving the ascending order. So, but nowhere we define any function for that, like how we do and all. So, because that is where we have used all wrapper classes. Wrapper is nothing but for all primitive types, there is one wrapper class is defined in Java. Means for int, there is integer. For char, there is a character wrapper class. So like this, so by default, those things will implement the comparable interface. That's why it worked there. But when it comes for the employee or student, it did not work like that. So because those are the custom, they are not implementing any interface. So explicitly we need to write the code. So these are like inbuilt. By default, these classes are implementing the comparable interface. That's why it worked there. Okay, that's it. So the magic core factor, deciding factor is this one. So you know everything is predefined and you are sure that it will not going to change. In such cases, you can define comparable interface because you can reduce one class for this. Okay, and it can be dynamic. So today they are asking for roll number and tomorrow the requirement may change from the customer. So you are not sure. In such cases, you choose comparator. Okay, this is how the sorting can be performed. So this sort is applicable for set and map and all these things. Okay, so all the same procedure remains the same, either comparable or comparator. That's it for today's class. Uh, we'll see tomorrow, whatever it is, like concurrent modification exception, and also like concurrent hash map. There are like concurrent classes are there within the collection itself. So we'll see all those. Suresh, like, can you stop the recording?